Hi, my name is Michael Goldberg, and I'd like to present my final project for Computer Science E63, which was a big data case study in medicine, specifically the application of Neo4j graph databases to global scale epidemiology. So recently, the Ebola outbreak in West Africa has shown us that infectious diseases are a leading cause of economic strife, disability, and death, and overall burden on a global scale. In addition, the outbreaks and how quickly they spread across multiple countries and continents is that there's a real lack of knowledge of the disease dynamics. That's to say how diseases spread within and among communities and on a global scale, how they interact with the environments, and their general epidemiology. To be able to better combat epidemics and future outbreaks, I think that we really need a better global scale understanding of the diseases to better combat and again predict future outbreaks. So in the last 10 to 15 years in particular, large-scale data efforts have been undertaken by national and international health ministries such as the Center for Disease Control and Prevention, the CDC, and the World Health Organization, the WHO. And these organizations have done a great job collecting and reporting disease cases, outbreaks, and epidemics, and have generated a large amount of data on diseases and countries on a global scale. And so now that we have data, and we're going to be generating a lot more of it, of very variable types, how can we scale our storage, querying, and analysis of this data? So Neo4j is a possible solution, graph databases in general, but I think Neo4j really has something special. So in particular, graph databases are a great idea for epidemiology because of the variable types of data that's coming in epidemiology, in addition to the sparsity of the data and how there's really often a lot of missing data, a lot of NA values, a lot of nulls, and a graph database such as Neo4j that is schema-less and can and works well with data that is this variable, this could be a very powerful use. Neo4j, just as a brief reintroduction, is something that we already saw in class in the middle of the semester. It's an open source graph database and it's very scalable. It's one of the most popular in the world. What's particularly interesting about it is that whereas most graph databases focus on storing data in the nodes, in Neo4j, it's optimized for storing data in the nodes and in the relations between the nodes and the joins. And in addition, it uses Cypher to query it, which is an SQL-like language. So in epidemiology, in general, a lot of analyses are completed in R, which is a statistical platform that we saw earlier in this semester as well. It's a really powerful platform that has a lot of great built-in methods for stats and for visualization of data. And recently there was a package that was developed called RNeo4j that's an API with Neo4j. So I wanted to use R and Neo4j together, that's to say RNeo4j, to analyze large-scale epidemiological data to show that it was quite powerful and very possible. So I looked at a database of human infectious disease outbreaks. It's from a Smith et al. Data paper from last year that shows over 12,000 unique outbreaks of human infectious diseases of many different kinds of data. The fields that are included are the disease of the outbreak year, biology about the particular diseases. I'd highly recommend looking a little bit more at the paper for more specification about the biology of these of the data fields. It's quite interesting. And so, in addition, I pulled in other data I pulled in data from other sources as well. I pulled in data on the disability adjusted life year, that's called a DALY, for every country in the world as measured by the WHO. So the disability adjusted life year is a good measurement on the general burden to health in a country. It's the number of years that are adjusted for disability that are lost in a country. So countries with that lose a lot of DALYs per year, corrected, of course, for the population size, are ones in which there's a lot of death, there's a lot of injury and that kind of stuff, whereas the countries with lower DALYs per year are ones in which the health is in general much better. So in joining the two databases, the WHO database on DALYs and the human infectious disease outbreak data, I developed a bit of a schema, which was a bit variable, for the Neo4j database. And this is it right here. There are outbreak nodes that include outbreak-specific data, disease nodes that include disease-specific data, and country nodes that include country-specific data. And so as I move here in the slide deck, I'm actually going to pause this video and move to part 2, which is a demonstration of the code. Thanks.